Hi, I'm Lenny Wells, professor of horticulture at the University of Georgia. I appreciate the opportunity to speak with you today. I was asked to give you a presentation on alternate bearing of pecan and some ways we could possibly mitigate that to some extent. So we should start off probably first by identifying what alternate bearing actually looks like. Most pecan growers are very familiar with this particular phenomenon. Um, when pecan trees reach a certain age, they will start to bear very heavily one year, and the next year, that production on those trees will drop off to a very light to no production. And then you will get into these big swings and cycles that play out through the life of the orchard if it's not managed in some way. There are a variety of things that come about as a result of alternate bearing. It's actually one of the most damaging uh, issues affecting the pecan industry as a whole. Um, but from the tree's perspective, it has value. When we look at it from the aspect of the pecan industry, pecan growers suffer from alternate bearing and the instability of cash flow. They can't really determine from one year to the next what their prices for the crop will be because it tends to fluctuate with low prices during heavy crop years and higher prices during low crop years. So it makes it very difficult for growers to plan in that situation. Um, Similarly, pecan processors have issues with it because their facilities and equipment can't run at full capacity in the off years. And pecan buyers also have uncertainty and difficulties with the market that's brought about from alternate bearing because they won't know from one year to the next how much they can promise their end users what they'll be able to supply. But from the tree's perspective, there are reproductive advantages or evolutionary advantages for this alternate or irregular bearing. And that comes primarily in the form of pest suppression and predator avoidance by having a heavy crop one year and not very big crop the following year. It can kind of throw predators and pests off to some extent, and they can't be as successful as if the tree produced every single year. So to really understand alternate bearing, there are two key terms we have to understand. One is induction. Induction refers to a stimulus causing the bud to change from vegetative to reproductive. And that stimulus can be something within the tree, such as a chemical or hormonal stimulus, or it can be an environmental stimulus, such as drought. Um, it could be disease. It could be extreme heat. It could be a variety of factors that affect it. But all these things sort of interact um, to affect induction or serve as that stimulus that affects induction. Then you have differentiation. Differentiation is the visible evidence of reproductive tissue development that you can actually see, usually microscopically, at a certain time of year. So everything we're talking about, and all the different ways that we're talking about mitigating alternate bearing affects one or both of these two factors. And these two factors are important at different times of the season. Um, the circle that you see here kind of shows the year uh, of pecan production and what we see taking place in the orchard, and then also what's going on inside the tree. So everything listed on the outside of this circle here is what you see in the current year in the orchard. So all the way from bud swell, then through bud break and pollination, and then as the nut starts to develop and you get into the gel stage and dough stage, and then you have shuck split, and then defoliation. Um, we see all of that going on the outside of the tree. But from the perspective of alternate bearing, there's important things going on inside the tree um, at different times of the year that are going to affect the following year's crop. The most important of those is what's going on in August. That's when flower induction occurs. So that's basically when those stimuli that we talked about earlier are deciding for that plant, whether it's going to, or for that tree, whether it's going to be reproductive or vegetative the following year. And then in March is when differentiation occurs. So that's when you actually get differentiation of those buds into either vegetative or reproductive. And sometimes you can have, they can be set through induction to be reproductive, but then you have issues that take place that we'll talk about that may revert those back to vegetative. So this is just to show you that there's a lot going on in the tree that affects this. In August, as we'll talk about, is primarily the most important month of the season, really. There's a lot going on in the tree, both for the production of this year's crop and for what takes place the following year, with the tree being able to return with a crop. So over the years, there have been a lot of different hypotheses as to what actually causes alternate bearing. And each of these, again, refers to things going on with differentiation or flower induction, and sometimes both of those. Early on in the 1930s, it was shown that starch concentration had a pretty strong influence on the fruiting of pecan. And then in the 70s, it was shown that starch in the roots was negatively correlated with the preceding year's yield and positively correlated with the following year's yield. Then in the 70s, Dr. Darrell Sparks did a lot of work on this, and he found that during on years, there's not enough carbohydrates in the tree to mature those fruits and then store carbohydrates for the following year's growth and fruiting. Ray Worley later discovered that exhaustion of the carbohydrate reserves could affect pistillate flower formation. And then later we saw that Bruce Wood in the late 80s and early 90s showed that indeed starch in the roots does partially play a role in alternate bearing. So it is an important factor in alternate bearing, but it's not the whole story. Harry Amling at Auburn University found in the early 80s that flower-inducing substances were produced by the leaves. And Bruce Wood and Mike Smith later found that floral inhibitors produced by the fruit, in conjunction with promoters produced by the leaves, appeared to regulate floral induction. And that has since been shown to really kind of be the primary factor involved in alternate bearing. So what it really comes down to is the ratio of leaves to fruit on that tree in a given season, usually mainly being determined in August. So the more fruit you have on the tree at that time, the more inhibitors are going to be produced, basically hormones. And if you have a higher ratio of leaves to fruit, you're going to have more promoters being produced that are going to promote fruiting the following year. So it's all about maintaining a balance between those promoters and inhibitors. And so basically now we're left with a two-level control for alternate bearing that goes on within the pecan tree. Primarily, again, it's the inhibitors and promoters determined during induction, during the growing season, by the amount of flowers and leaves that are there on the tree. And then also secondarily, the dormant season carbohydrate pool determines pistillate flower development. So basically, if there's enough carbohydrates there to support those flowers that are being induced in August, if there's enough carbohydrates there in the spring, then everything flows along normally and you get good production. If there's not enough carbohydrates there, then you can get reversion of those reproductive buds back to vegetative buds. In 2004, Bruce Wood, Patrick Connor, and Ray Worley developed a alternate bearing index. And alternate bearing index is basically a rating of alternate bearing from 0 to 1. There's a formula you use to determine that alternate bearing index. The closer it is to 1, um, the more alternate bearing the variety is. Um, and it was shown that this alternate bearing index was not associated with fruit ripening date. So it's not really associated with, a tree, a certain variety producing early, say Pawnee, versus something like Sumner that produces late. Alternate bearing is not really related to that. We do see that alternate bearing index increases with the longer post-ripening foliation period. So what that means is that you get more alternate bearing actually the longer those leaves stay on after that fruit is mature. We also see that late season leaflet retention decreased with earlier fruit ripening. So, for example, Pawnee, they produce nuts very early in the season. We start harvesting them here in September. They're also one of the first to lose their leaves after that fruit ripens. And then late in the season, we see that photosynthesis rates generally are lower with those earlier fruit ripening varieties. So um, they kind of start to shut down a little earlier in the season than those that fruit later, or that their fruit matures later. And Bruce Wood also showed that gibberellic acid inhibited return bloom um, in on and off trees. So in trees that were alternate bearing, in a heavy year, and in those that had a light year. And upon further investigation of this, what he saw was that gibberellic acid increased the return bloom of trees that had an on year. So if you have a tree or an orchard that's got a heavy crop and you spray gibberellic acid, that tends to help it come back with a return crop. But you don't see that same effect if you spray trees that have a light crop on them. You don't see that stimulating more return blooming than not. And some of the later work that was done on alternate bearing, this is where uh, a lot of the current thinking on alternate bearing comes a lot from the work that Charles Rolla did. Charles Rolla was a student of Mike Smith's at Oklahoma State, and he's now with the Noble Foundation. But they looked at the effect of cluster size and shoot type on return bloom and on the non-structural carbohydrates. And what they found was that thinning the fruit to 3 or less per cluster improved that return bloom most years. When they thinned it down to 1 fruit per cluster, it produced return bloom pretty much every year. But fruit thinning, even though you would get a return bloom with fruit thinning, you did not see that affected stored carbohydrates in the root system. So that tells us that carbohydrates are not the main thing driving alternate bearing. They also saw that large crops do reduce next year's crop, but that relationship is not absolute. It doesn't happen all the time. A good example here is that fruit development reduced return bloom of Pawnee. But if you had trees that were very vigorous and very healthy, that relationship between crop load and return bloom was weak or not existent at all. So when they're heavily overloaded, then you could see an effect. But generally, if trees are in a good, healthy state, they can maintain some level of good production and still come back with a crop. But there is a breaking point to that where they can have too many and then not come back with a crop. They found that return bloom of individual shoots appeared to be more regulated by the entire tree's crop load rather than just cluster size on that one shoot. So it's really, in many cases, it's more of a whole tree effect that you're looking at rather than what's going on in an individual shoot. Interestingly, they looked at alternate bearing by variety. So they took a couple of varieties that were very light alternate bearers, as you can see from the alternate bearing index there. Colby and Peruke did not alternate bear that severely, while Giles and Osage are more severe alternate bearers. And what they found was that fruit development did not suppress return bloom in those low alternate bearing cultivars. They could carry a crop every year, but they may not carry so much that it kept them from producing a crop the next year. But in those severe alternate bearing cultivars that produce really heavy crop, that's where you would see those alternate bearing swings. And again, those non-structural carbohydrate concentrations in the roots and shoots during January were not related to the previous crop load or to subsequent flowering. So again, this points to the carbohydrates in the tree not being the primary control of alternate bearing. It's more related to those inhibitors produced by the fruit and the promoters produced by the foliage in a given year, affecting the following year. So there appears to be a multi-level control of pistillate flowering in pecan, consisting of floral induction, which takes place in August. That is mediated by a growth regulator balance derived from developing fruit and mature leaves. So that's where the leaf to fruit ratio becomes important. That's the primary form of, that's primarily what controls alternate bearing. But then also you have stress that can come about. So you want to avoid stress during the growing season. This can lead to low carbohydrate reserves. This can come about through poor nutrition, drought, defoliation, a number of different factors that can affect this. But that stress during the growing season, which lowers those carbohydrate levels in the tree, results in a reversion of that induced meristem. And what that means is those cells in that tree that are induced in August to be either vegetative or reproductive. If you have a lot of stress and lowers those carbohydrate levels and they don't have enough carbohydrates going into the spring the following year, those cells that have been induced already to be reproductive can revert back to being vegetative if they don't have the carbohydrates to fuel that production. You need adequate stored substrates or carbohydrates to support flower differentiation in the spring. So what are the potential tools for controlling alternate or biennial bearing? Number one is the cultivar. As we mentioned, there's a lot of difference in cultivars related to alternate bearing. Some alternate bear very heavily, some do not. Some factors that affect that is the post-ripening foliation period, the cluster size on the tree. Usually if you see a variety that has more than 3 nuts in the cluster and that it starts to produce early in the life of that tree, usually that means it's going to be a pretty severe alternate bearer. So cultivar plays a big role in it. Within that, We need to minimize the environmental stress on those trees. That involves water, it involves sunlight, it involves the fertilization that we provide those trees. You want to make sure they have all the nutrient elements that they need. It involves foliage pests and diseases. You want to keep the foliage healthy, and keep the trees healthy, especially as we get into August, because that is the critical time when induction takes place, and you want that tree as healthy as possible during that time. There's been a lot of talk about late season fertilizer helping the trees to come back with a better crop the following year. In the research that's been done on that, the results have been variable. Sometimes we have seen that helped with return crop. Sometimes we've seen it did not help. I think really what it boils down to is if we just keep the trees healthy, they get the nutrients that they need. Pecans primarily use the majority of, say, the nitrogen that's applied to them just after bud break. 2 or 3 weeks after bud break is when the greatest nitrogen demand is. And then they'll need some later on in the season. But as long as we maintain that, I don't think the timing is so critical, aside from that spring application, to make sure they have enough in the spring, and then just keep those trees healthy through the season. And I don't think in that case, the timing, whether you do that second application in June or do the second application in August, I don't think it really matters that much. We just need to keep these trees as well fertilized as we can. Minimizing physiological stress, most of the time this is a result of just the crop load on the tree. And so we have to manage that crop load. And this is the number one factor, the number one management tool that we have in preventing alternate bearing is managing the crop load. That can come about in two different ways. One, through mechanical shaking of the trees, usually the first or second week of August, or coming in and doing hedge pruning, which we'll talk about as well. And then there are flowering regulators. So promoters that could be applied in the off years, ethylene, cytokinins, inhibitors that you would apply during the on years, like gibberellins and auxins. There's not been a lot of research done on this. At least there hasn't been here in the U.S. There's been a little, but at this point, it's not something that we're pursuing, because you have to go through the whole labeling process and all, and that could be difficult. So at the moment, that's not an option for most growers in the U.S. Maybe a different story down there for you guys. So managing the crop load with mechanical fruit thinning. Not a lot to say about this. I mean, it's pretty straightforward. You would go out and just shake a few nuts off the tree, usually during early August is when we normally do it for most of our varieties. There's a timing window that's very important for this. The way to determine if the trees are ready or at the stage that they're ready for this is to slice the nuts longitudinally. And that picture at the bottom, you can see shows what you're looking for, is that U-shaped cavity that you see in that nut on the right. You can see that the tips of that U-shaped cavity extend to about 3/4 the length of that nut. And the nut on the left, that the tips of that U-shaped cavity only extend about 1/4 of the length of that nut. So if you make that slice into the nuts and look at that cross section, what you're looking at is you want that U-shaped cavity, you want the tips of that cavity to be about half the length of that nut. At that point, the trees should be large enough that you can go ahead and start to shake them, to shake some nuts off. If the tips of that U-shaped cavity get all the way to the the end of that nut all the way to the tip, you could still shake the trees and get improve your nut size would improve, your percent kernel would likely improve, but you would not get the benefit that you want for return bloom. To get the return bloom benefit, you have to start to shake the trees when that U-shaped cavity has extended to halfway to about 3/4 of the length of that nut. If you get all the way out to the tip, it's too late. Um, but it's been shown time and again that mechanical fruit thinning very much evens out production. It stops you from having those big up and down swings in your production. And it's the most reliable method of doing it. Hedge pruning can also serve the same purpose. Um, we've done work here, hedge pruning in the dormant season and hedge pruning also in the summer. We don't really see any difference with regard to how the tree responds to hedging in the summer versus hedging in the winter. As far as yields, nut size, nut quality, health of the trees, they respond equally well. But when you're hedge pruning, there's a lot of benefits to it, but one of those is that you are managing that crop load, because when you cut the limbs off, you're also cutting off fruiting wood. So you're cutting off some of next year's production. But you don't do both sides of the tree in the whole orchard every year. Then you'd be cutting off a lot of your production. You just want to kind of minimize it. And so what we tend to do is we'll do every other middle. So we take one side from the row on the right and one side from the row on the left, and we'll top that side as well. So we're reducing the crop load, but we're not eliminating it. So hedge pruning is very useful for that. And it's a lot easier on the tree, really, because with fruit thinning, mechanical fruit thinning, when you put the shaker on the tree like that, you risk damaging the vascular system, damaging the bark on that tree, and with it, the vascular system that provides it with nutrients and water. And when the water is flowing in that tree like it is during August, the trees are very susceptible to that damage. With mechanical hedge pruning, you avoid that potential problem. All right, and so then we come to managing stress on the tree. That's an important season-long strategy that we need to employ, but it's especially critical in August during that late water stage when that induction is taking place. So at that time, we need to make sure the trees have all the fertility they need. The irrigation is adequate. They've got plenty of sunlight, and we keep the insects and disease away from them. And again, photosynthesis, for photosynthesis to take place, you've got to have water and sunlight, and all these factors kind of play into that. And so that's really what we're trying to manage at that time of the season. Just keeping the tree completely free of stress. So to kind of sum up, alternate or irregular bearing is an innate characteristic of the pecan tree's biology. It's controlled at two levels. Primarily, it's controlled by the growth regulator balance. So the amount of promoters and inhibitors in that tree in August, that relates back to that leaf to fruit ratio on the tree. And we can manage that again by managing the crop load on that tree. And then secondarily, we want to maintain carbohydrate levels by avoiding stress. That's going to reduce the reversion of induced meristem from reproductive to vegetative, and supports the flower differentiation that's occurring in the spring, so that those buds will be reproductive and develop fruit. And then also, we can manage this by manipulating the tree's tendencies for our own advantage. Again, managing that leaf to fruit ratio, managing the crop load by either mechanical shaking or hedge pruning, and then avoiding those late season stresses are particularly important. And then also, I think we have to manipulate ourselves and our own tendencies. We as humans and as growers have a tendency to get greedy, and when we see a tree with a heavy crop load, we kind of start looking forward to what's going to come when we harvest that crop. But we need to realize we need to think ahead and think about what's going on in that tree that's going to affect next year's crop and manage because when you're growing pecans, you're not only managing for this year, but you're managing for next year as well. So thank you, and I hope I've done an adequate job of giving you an idea into alternate bearing.